Having spoken about the difference quotient and then finding the first principle derivative, okay, now let me introduce you to the concept of limits. What we have been actually doing is finding the difference quotient and then trying to look at what happens as the change in x tends towards 0, or the change in x is almost negligible, it's 0. What are we actually doing? We are taking a limit. We are taking a limit delta x tends to 0. So what do we actually mean by this word limit? What are we doing? Let me just throw a little more light on it. Now we have been looking at delta x, right? Delta x, which is x minus x naught, the change in x, okay? Change in x, okay, the variable x, okay, the independent variable x. So the change in x is delta x, and what we are looking at, what happens as delta x is tending towards 0, that x minus x naught is actually almost negligible, it's almost 0, so what is happening? What is happening is that we are actually looking at what is happening when x and x naught are almost same So actually, x is tending towards x naught. Instead of writing x minus x naught or delta x tends to 0, I can even write that x tends to x naught, right? Now x tends to x naught. Now this is a very tough limit. This is a tough limit. Why? Because what is happening when I am looking at the difference quotient? My delta x is in the denominator. Delta x is in the denominator, and that I am saying that this almost turns into 0. This is 0, okay, and then what will be the value? It's undefined. Anything where denominator is 0 is undefined. So what are we actually implicitly assuming in our head? We are implicitly assuming in our head that x will not be equal to x naught. It will almost be reaching x naught, but it will not be equal to x naught. And that's what is the concept of limits. The concept of limit actually talks about the journey and not the destination. What we are interested in is, we are interested in knowing what is happening when I am reaching a certain point. I might not reach exactly that point, but what is happening when I am reaching that point? So that is what is the concept of limit. Now certain limits are easy. Certain limits are very easy. Now limit of a function is essentially found as x tends to x naught. We say that fx tends to or approaches a certain finite limit L. This L has to be finite, okay. So as x tends to some place, f also tends to some place. So some very simple limits, like you have a function x square minus 5 upon x minus 1. When what happens to this function? This is fx. Fx is x square minus 5 upon x minus 1. We want to know what happens to the function as x approaches 5. Okay, as x approaches 5, or I can say that x minus 5 approaches 0, or you can say that delta, this is my delta x which approaches 0. Okay, so in any case, so I can just put 5 as at the place of x. So 5 square minus 5 upon 5 minus 1 gives me a simple solution, which is 5. The function is also almost 5 when as x approaches 5. So as x approaches 5, fx approaches 5. As x approaches 5, fx also approaches 5. Okay. But certain limits are definitely not easy. The forms 0 by 0 form, anything where you have denominator as 0 will be very difficult to find. Those limits are difficult to find. Limits like, for instance, let me just give you a graph. A graph like this. A graph like this. Okay. So I have a graph where I am saying it cuts the x-axis on -2 and moves ahead like it. At 2 it breaks. At 2 it breaks. So what is happening to the function is that it's coming from here till here and then from here to here. Okay. So at 2 we have two values. One is 3, the second is 4. One is 3, the second is 4. So what is happening is that when the function, as the function is approaching from this side, the value of the function around 2 is 3, and as the function is approaching from this side, the value of the function around 2 is 4. So can I say the limit of this function exists? And in case I say that the limit of this function exists, what will it be? 3 or 4? I really can't say that, right? So now what is happening, from different directions, the function is taking a different value. So that's not a good thing for limit. So what is happening from the left, where your x is less than x naught. X naught is say 2. 2 is my x naught. X is less than x naught. 2 is my x naught. 2 is my x naught, and x is coming from this direction. Then it is 3. I say that it is x tends to 2 minus sign is for left. Okay, minus sign is for left hand side limit. We call it a left hand side limit. Okay, and here you have the other thing from the right. Just look at these arrows. I have given you these arrows such that you understand what we are talking about. When I am coming from right, what I am trying to say is limit from right means that I am coming from right towards left, and from left it means I am coming from left towards, moving towards right. Okay, so this is denoted by 2 plus, and fx equals to 4. So a function like this function is almost like a function say x plus 1 when it is less than 2, and it's x plus 2 when it is greater than 2. So here what is happening? Here what is happening? The limit does not exist. Why? Because the limit from left hand side and right hand side differ. They differ. So that means the limit does not exist. And when the limit exists, the left hand limit should equal to right hand limit, and that will be the limit of the function. Okay.